Hey everyone, my name is Neha,
I'm Gayatri.
And I'm Ekta.
and today we're going to explore how news vendor problems are a reasonable model for the process of ordering flu vaccines. We'll discuss why this parallel makes sense and delve into the complexities surrounding vaccine distribution during flu seasons.
First, let's discuss the objective of news vendor problems as a classic inventory decision model. In this kind of problem, a vendor must decide how many newspapers to order for a given day, balancing the risk of ordering too few and running out of stock against the cost of ordering too many and having papers that are unsold. This decision is often made under uncertainty as the exact demand for newspapers is not known.
Vaccine distribution is similar to the news vendor problems we study in class because they both have the same core concepts. Both have back order, holding, and ordering costs, a price to sell goods at, and uncertain demand. Back order cost is the cost a company pays for not having enough goods to meet demand, and holding cost is the cost to store excess goods.
Right, so now specifically, let's apply this concept to the procurement of flu vaccines, focusing on the H1N1 flu outbreak of 2009 as our general example. Ordering vaccines is indeed very much like the news vendor problem because, as Ekta said, it involves the same fundamental trade-off between ordering too many vaccines or too few.
So for the first scenario, imagine if the government orders an excessive quantity of flu vaccines. This would lead to several costs. First, there's the cost of purchasing the excess vaccines, which can be quite substantial. Then there's the cost of storing and managing the surplus vaccines, which includes refrigeration, security, and logistical expenses. Moreover, ordering too many vaccines can result in wastage if they expire before they're used. So these costs can indeed be described in monetary terms.
On the flip side, if the government orders too few vaccines, it risks running out of supply during the flu season. This can have severe consequences, such as a public health crisis, increased hospitalizations, and even loss of lives. The specific monetary cost of having too few vaccines can be the revenue lost by not selling a unit of good that there was demand for. It can also be the cost of someone falling sick with the flu because they could not get a vaccine. For example, it could be the hospital bill. The cost of ordering too few vaccines can be enormous and extends far beyond monetary terms, affecting public health and well-being overall. As discussed just now, the risks associated with over and under ordering vaccine inventory are drawn from the article in reference number 2.
Right. So now, why is there uncertainty in the demand for vaccines during flu seasons, right? Well, several factors contribute to this uncertainty. According to an article in the National Library of Medicine regarding optimizing cold chain vaccine networks, first, the flu virus mutates, making it challenging to predict which strains will be prevalent each year. Second, the willingness of people to get vaccinated can vary, influenced by factors like public awareness, vaccine efficacy, and the severity of the flu season itself. Third, unforeseen breakouts like the H1N1 pandemic can significantly alter the demand patterns.
To characterize demand uncertainty, it would be a good idea to model the data as a plus-1 distribution. Modeling vaccines would be a discrete distribution since you can't technically have a fraction of a vaccine. It has to be a whole number. Additionally, as described in the prompt, governments have to order and prepare these vaccines months in advance, which is an indication that we are looking at the vaccine demand over a designated time frame. And all of these criteria make it so that a Poisson distribution is the appropriate choice to model demand. To characterize demand uncertainty, we can look at historical data on flu seasons, conduct surveys to gauge public sentiment, and collaborate with healthcare providers to estimate demand based on at-risk populations. However, it's important to acknowledge that this uncertainty remains a challenge in vaccine procurement.
Finally, let's discuss some additional complications specific to managing the distribution of flu vaccines compared to the simple news vendor problem. These complexities were found in an article from the National Library of Medicine about the optimal number of vaccines to order at clinics. First, we have cold chain logistics. Unlike newspapers, vaccines are perishable items that require precise temperature control throughout the supply chain process to maintain their effectiveness, which adds to the complexity and cost of the distribution. Second is priority groups. Vaccines are often allocated to priority groups such as healthcare workers and vulnerable populations, which introduces a layered decision-making process beyond a single order quantity. Third is multiple suppliers. Governments often procure vaccines from multiple suppliers, each with their own lead times and pricing structures, which adds further to the complexity of the ordering decision.
Yeah, so in conclusion, using news vendor problems to model ordering flu vaccines due to the shared trade-off that we discussed between ordering too many or too few units under demand uncertainty that's how the problem is modeled. But however, the stakes are much higher when it comes to vaccines, since the consequences of ordering errors extend beyond monetary costs all the way to public health and safety problems. Managing vaccine procurement effectively is a critical task that requires careful consideration of both economic and health-related factors. So thank you so much for listening. This is an important problem to tackle, and we can use news vendor models to do so.